So this situation, we have the object close to the mirror, specifically in front of the focal point. And so something different is going to happen for this situation. So we'll follow our rules. The rules are basically the same as yesterday. There's some subtle differences, but the basic idea is the same. And so rule number 1, if I were to summarize rule number 1, what would it be? Well, we go parallel first, and then how does it reflect? Through the focal point. So if we were to summarize that, we just say we go parallel and then reflect it through the focal point. So let's go ahead and draw that one out. Beam number 1. I'm going to draw this parallel. And again, parallel just means parallel to the surface. And again, we're going to go back to that vertical, slightly behind the mirror. We're then going to reflect this beam through the focal point. Okay, so that's beam number 1, parallel focal. If we were to summarize rule number 2, what would it be? The opposite, right? Focal, focal, and then parallel. Well, notice we do have a slight issue here with this one if you take a look at it. And that is, if we were just to draw it straight through the focal point, what would happen to it? Would never even hit the mirror, right? And so what you do whenever this situation happens is you take your ruler and you're just going to aim it with the focal point. So you aim it with the focal point like this, but you don't draw it through the focal point, you draw it to the mirror. So you're just going to take your beam, aim it with the focal point like this, and then physically actually draw it to the mirror. If you want it, I'll dot this just so you see it's aimed, but it's not actually going through it. You send it to the mirror. Okay, when it hits the mirror, or the part behind the mirror, what happens to it? It's going to reflect parallel. Like that. That is beam number 2. Okay, beam number 3. If we were to summarize beam number 3, what would it be? Through the center, yeah. So beam number 3 is center. I'll just write center to center, meaning it doesn't change at all. Just goes through the center and back through the center. So just like we did on that last one, what you're going to do is you take your ruler, you aim it with the center, you're going to send it towards the mirror, but it's just going to reflect straight on back. This way. Okay, so that's beam 3. Alright, what are we looking for? What did we look for yesterday? An intersection. Yeah, three-way intersection. Well, what do you notice is what's going on with these beams? They're not intersecting, okay? Specifically, they're spreading apart from each other, or the word that we use is that they are diverging from each other. These are diverging beams. So here's what we do when we encounter this situation. Okay? These are not going to form an image over here. However, if I were looking at this, let's say this is my eye right here. I'm looking at these beams and they're coming into my eyes. Now, according to my eyes, how should light travel? straight line. So according to my eyes, light should travel straight. Our brains cannot comprehend the fact that there's some reflection going on. So what that means is, to me, it appears like each of these beams are coming from somewhere behind the mirror in a straight line. So what you're going to do is you're just going to take your 3 beams and you're going to project them backwards onto the opposite side of the mirror, and you're going to see where it looks like they're all coming from. So beam number 1 is this one, the one through the focal point. So I usually make little dotted lines just so you understand it's not really going through the back, it just appears like it because that's how we see, or think we see at least. That's beam number 1. Beam number 2. Now if you notice here, there's actually 1, 2, 3, 4, 5 lines. So a big mistake is recognizing which you go back. You don't send all 5 back. You only send the 3 that were reflected. These are the 3 that are actually going into your eyes. Those are the 3 that you think travel straight. So beam number 2 is right here. Let's send back beam number 2. This is the one that was parallel. Whoops. That's beam number 2. And then beam number 3 is easy, it's the only one. So it didn't change at all, so that's the green one here. Okay, so if you did it right, you should have a nice 3-way intersection. Remember, that represents the tip of the arrow. So this is the tip, that's what we're starting with, that's the tip. So if we continue, let's draw the rest of our arrow. Looks like that. So that's our image. So what do you notice about this image?
It's larger.
It's larger. Good. What else do you notice? It's behind the mirror. Okay, so let's just give some characteristics. So it's larger. It's behind the mirror. Is it inverted or upright? It's upright. And then what do you think? Do you think this is a real image or a virtual image? Virtual. So remember, the image is not actually there. If you were to put a screen here, nothing would show up on it. It's only there because your eyes and your brain think it's there, but it doesn't actually exist. You only think it does. Let's go ahead and physically measure this out. Let's see what we get when we measure. So I'm getting a distance of about 3.5. Is that about what you guys are getting? 3.4 maybe, 3.5, 3.4, 3.3. So just write down whatever you happen to get. We're going to figure out who's right in a few minutes. Go ahead and measure your H. Looks like about 3.3. Hopefully you're in that ballpark, 3.3, 3.2, 3.4, something like that. Alright, let's go calculate it. Let's see what we should be getting. So the equations are the same. If we drew it perfect, let's see what we should have gotten. Okay, 1 over di plus 1 over 2 should equal 1 over 5. And you should be getting negative 3.33. So what's the meaning of this negative? Behind, good. So this is behind. So actually up here I should have made this negative. Whenever the image is behind the mirror, it has a negative distance. Okay, so I was fairly close. Did anyone actually get 3.3? Ooh, wow, a bunch of you. I think Brittany's it. Weren't you the superstar yesterday too? HI over HO equals negative DI over DO. So let's see what we get for D. Well, we should have gotten for HI. If we drew it perfect. 2. Notice negative, negative, negative. Oops. Too many negatives. Negative, negative. And DO was 2. So that's easy. HI should be positive 3.3. Positive 3.3. What does a positive mean? Okay, so this means upright. Good. Be careful, positive does not mean larger. Positive height does not mean larger. Positive means that it's upright. Let's calculate magnification. Plus, this looks like it's 1.67. Again, what does the positive mean? No. Positive means upright. Okay, positive means upright. So be careful. Positive means upright, negative means inverted. For both magnification and for height, both. Now what does the 1.67 mean? That means it's larger. So anything over 1 is larger, anything decimally, okay, less than 1, between 0 and 1 is smaller. Okay, any questions on this guy?